All right, class.
Yes.
Thank you. All right, good. All right, since we're all yesing, we're all here. Okay, so definition. Okay, what we're trying to do is actually finding the area under the curve. So mathematically, it comes out to figure out my delta x is which is going to be the width of each one of my rectangles. We get this information here. We get it from there. That's my delta x, b minus a divided by n. So that's going to be the width for everything, and the height is based on the function of that. So that's where we get this whole thing, where we actually haven't talked about integrals yet, but we will. So it's of the function of delta x, which is going to be the width of each one of the things, and area under the graph could be also in this form. It's the limit of the sum of the parts from n to infinity. So if we take an infinite number of slices, an infinite number of rectangles, that's where we get the actual value. So as we take it to infinity, that's where we get what it actually is, versus what we were doing yesterday, which was estimating, right? Because we have an overestimation and underestimations, none of them are really truly exact. So we'll go with that. So for this one, find the area under the graph from this function right here, 0 to 10, using upper sums. Okay? So let's go ahead and let's use upper sums. So I'm going to break it up into different units. So let's start with 2. Let's start with 2, just like we did the other day. So if I did 2, okay, so that means that in between 0 and 10, there would be 5. So 10 divided by 5 is going to give me 2. So my delta x, the width of each one of my rectangles, are going to be 2. So that means right here on my graph, I'm going to go up to 2 here. Boop, 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 boop. So all those there are now my rectangles. And I said upper sums. That means that I need to box them off from the upper side of each rectangle. So on from 0 to 2 would be, is that the right side or the left side? Right, because that's my upper, right? Yes?
Yeah.
Okay. So we're talking about uppers and lowers, and then sometimes we'll refer to it later on as a left hand or a right hand estimation. So that means all of them we're going to have either a left side or the right side. So here on this problem, these are all going to be right side. So if I were to do my math here, so looking at this, is this going to be an overestimation? Say yes. Yeah, this is going to be an overestimation here because we've done the upper on each one of these. And it is above my line. My rectangles are all above my line. So my delta x is going to be 2, right? So from the formula that we did earlier, I'm going to say 2 is on the outside, right? Yes? 2. This is what we did yesterday. Because I'm factoring out that common delta x. So it's 2. And on the inside, it would be f of 2, right? All right. Denny, are you following on this? Are you sure? Where'd I get the 2 from? Yeah, because we have 5 parts, and that's the width of every single one of these. So we have 2 from here to here. So this is referred to as my delta x. So if I was going to go through formulas, my delta x would be out front. Okay, so whatever my width is, that's my common factor. Because when we did it yesterday, I was able to write everything out like this. All of them had a common factor of 2, right? And 2 was the width of every single rectangle. And so by doing that, I was able to pull this out, and now I can rewrite it with only just the inside here. So instead of actually doing all the parts individually, multiplying it, and then adding it, we could simplify it and just do this at the end, right? And that's what we're trying to go for. So next one's going to be f of what?
F of 4.
Very good. Plus f of?
6.
Plus f of?
8.
Plus f of? 10, right? Because it's all the uppers there. And using my function, 2, f of 2 is what?
Hold up.
6 plus 12 plus I'm going to do a bit of mental math here, because why not? So I got 30, 60, 90,
Okay.
100. Yeah, 90.
No.
Yeah.
Wrong.
So 90 times 2.
180. Will it always be in units?
Its area. And these are normally on a graph, so you will have units and units squared. Okay, let's pretend that I was sitting in a geometry class yesterday, and I'm like, dude, we just learned what these shapes are. What shape is this thing right here?
Right triangle.
It's a right triangle. It's a right triangle. So how do I find the area of that?
Area.
1/2 base, which is 10 times height. Okay, so that's going to give me, what's that going to give me? That's going to be 300 times half. So my area is so I figured out it's supposed to be exactly 150 units. And then my approximation came up to 180 units. So I can clearly see that I had a overestimation by doing that, or the upper on each one of these. Does that make sense now, hopefully?
Yeah.
So yes, you can just look at it and be like, hey, that's a shape that I know. Okay, here's another one. I want you people to set this one up and do this one yourself.
Did you print it twice? Not a problem.
Okay, so let's make this one as n equals 1. And you notice I screwed up here on mine.
Okay, so it is.
Yeah, so right here, this is basically to get the delta x, I left it on there, but yeah, I should have changed the numbers. So get the delta x, it's b minus a divided by n. I was hoping you guys would actually get this one pretty quick. Delta x would give me b minus a, 4 minus 0 divided by 1, which is 4. So that means that the width of my rectangle is going to be 4 units. From here to here is 4 units, isn't it? Okay. And we're using the lower sums. So in this case, is it going to be the right-hand side or the left-hand side?
Right hand.
It's the right-hand side, right? So my delta x is 4 times f of what?
F of x sub 1? Is that sub
No, you're not using these. What number are you using? Not 1, 4. Because right here, the x value, because this is your delta x over here. Okay, that's the width here. And so the right-hand side, which is the lower end, right, is going to be here. So that's going to give me, I only have one rectangle. So what is f of 4? Yep. So I have one rectangle with a height of 0. Didn't we have something like this yesterday?
I really hate that shit rectangle.
Okay, let's. Why? This just is showing that the lower side is going to be down here now.
Makes me think I should solve for that one instead of.
Okay. Here, how about this instead? N is 4. So you're going to do this now from 0 to 4. From 0 to 4. And your n's going to be 4. So you have to find delta x first. You're really just checking messages and stuff like that instead of actually doing notes? Yeah, that explains a lot. Okay. So, you're doing another one. Okay, so what's your delta x? 4 minus 0 divided by, what's my n? 4, which gives me 1. So delta x is 1. So that means that each one of my rectangles is going to have a base of what? 1. Each rectangle has a base of 1. So I'm going to be at 1, 2, 3. So each rectangle now has a base of 1. So draw the rectangles. And this is from lower sums. That means it is the lower end of each one of my rectangles. So from my formula, I'm going to have 1 on the outside, f of, let's see. So my lower side looks like it's going to be this over here. My lower side is this over here. Lower side is this over here. Lower side is this here. So my first function is going to be f of what? 1, because that is the lower side, plus f of 2, plus f of, plus f of, find the values, plug it in. So, if I plug in 1, what do I get? Yeah, 15. So 1 still on the outside, plus plug in 2, plus plug in 3, 7, plus plug in 4, add them all up. 34? Times 1. Anyway, so hopefully that helps. Now, the delta x, is that what you guys are struggling with this one on this? Having to make each one of yours own intervals? Melissa, is that what was happening there?
Yeah, I think so.
Huh?
Yeah, I think so. It's just an interval. Because I look at the sheet of rectangle now, and I'm like, what have you want?
So we go with what our interval is here, and if it's delta x is 1, in this case I'd start at 0, and then my next one would be at 1, 2, 3, all the way to 4, and that would be all my corners for my rectangle.
Okay.
So It's just the one that was there that actually messed you up?
Existing rectangle for no reason.
Okay. Alright, it's trying to be a good example to go along with this, that you would actually have to just keep going from there to there for each one. So, I guess not. Alright, that being said, everyone's gonna like, share, and subscribe, hit that notification button, support my channel, and buy stuff from the merch store. I'm gonna finish posting the homework. I did not